Look at me being 30 minutes late once again. And at that, I've already wasted 4 minutes at the beginning of the stream here, but hey everyone, JSD Cool here, and welcome back to the coding streams, which are maybe gonna be a regular thing now. I actually do not know when the green screen is not perfect over here, but it doesn't matter. At least not currently, it doesn't matter. Anyhow, yes. Today, in this live stream, what we are hopefully going to accomplish is we are hopefully going to be implementing real-time shadows and processing via a very simple and basic method of rendering it twice. Or shadow mapping is the proper name for this technique, and I'm going to start by kind of explaining how it works. Yeah. Alright, so basically what shadow mapping is, well, it's one of the easiest to implement and cheapest techniques for doing shadows, but it's also one of the least good-looking techniques because it's not particularly advanced. Obviously, the most computationally intense and best-looking technique for shadows is ray tracing, or path tracing, whatever you call it. But obviously we're not doing that. One, I technically have a GPU capable of ray tracing. My Intel GPU is capable of ray tracing. At least Intel says it is. I've never run into anything that can use its ray tracing cores, but that's what it is. But we're not doing that. Also, OpenGL doesn't support that. That's what we're using under the hood here. So, in terms of what shadow mapping is effectively rendering the scene twice, as I said. So the first thing you do is you'll render the scene from the perspective of the lights. Well, yeah, you'll render the scene from the perspective of the light source. But instead of actually doing rendering, you just calculate the depth from the camera effectively of everything and whether or not, I guess, it's visible. Then you transform that back into being rendered from the perspective of the actual camera that is generating the image, and that is what is then called the depth buffer. That is then used in the actual rendering of the object itself. My brain just farted there. That is then used in the rendering of the actual final frame itself to determine the actual, or whether or not a pixel should be in shadow or not. It's a little bit complex, but hopefully we get there. I also do have Tyler on the call here. He does appear to be back. Hey, we'll stop in and say hi with him, and he'll be joining us, I guess, throughout the stream while he works on homework and I work on this, hopefully. Hello, Tyler. I'm doing a stream now because you took so long to get back. I can see.
Wait, you live?
Yes. It's been a while since you've stopped in on one of these live streams. Mutes himself. Okay. I mean, you can talk on the stream as long as you don't talk about as long as you don't get the stream demonetized or dox yourself or anything, Tyler. Okay. Anyway, back to the actual stream in it of itself. Alright, so this is what I have so far for the scene. We have a big box and a little box on top of that big box, and obviously we want to project the shadow from this thing onto this. As currently from this static camera perspective, we don't know where it is in space. I mean, it looks like it's there, but how close to us is it? Is it, doing any of that? So obviously we're making use of shaders to do this, but there's a little bit of groundwork we have to do first before we can actually run these stuff. So first thing we got to do here is we got all this stuff set up. We gotta deciding what to do here. So SHADER. I'm gonna put this shader. Yep, the shadow. Okay, actually, I should, I explained it. We have the two shaders here. The shadow shader, which is what we'll actually end up rendering to our screen for the actual shadow itself, and the depth buffer shader, which is what we'll be calculating the depth buffer. So we do that, and that'll set up all this stuff to render with that shader, which should be exactly identical at the moment. No, it's not, because I didn't include, right, because lighting-wise, I didn't include that. Oh. Okay. Well, that's the first thing I guess we have to do, is we have to go and change the shader. So I just used the I put everything in with the default OpenGL shaders, and completely forgot that I should probably have used the lighting-based OpenGL shaders. I did copy those into the project just in case we would need them, I guess. Oh, I just deleted them. That's not right. Edit those with Notepad++, please. Oh my gosh, Tyler. Tyler, so I'm not going to be looking at your camera on Discord all that often. And that's not on stream, by the way. Which I guess you could see for yourself if you wanted to view it. But yeah, just to give you guys an idea of how significantly more complex the OpenGL or the, I guess, lighting-based shaders are than the non-lighting-based shaders, because this is the basic shader, which just is everything at the flat color. It is this simple. And this is all the stuff that happens when lighting is involved. Yeah, it's kind of a lot. So we're gonna just kind of ignore this for now. Admittedly, this is the even more complicated working with a texture version shader, and I should have grabbed the just lighting based shaders, but you know what, we will deal with doing that later. I first want to just get something working, I guess, and we can get proper coloring of anything in later. Okay, so, and the vertex shaders also won't be particularly important, but they are here in case we do need them. Anyhow, so the second thing that we're gonna need to do here, so we got that shader applied. We're going to need to obviously have the depth buffer. Now, I think the only way we can do this in Tyler is by in processing is by rendering it, effectively rendering the whole thing twice. And by that I mean literally just creating a separate render object, taking the output from that and passing it into the first. So actually, I'll create that object out here. P graphics depth buffer. Now, BUFF for. Now, I don't remember the syntax for this. Create graphics. For now, we're going to make it the same resolution as the main sketch, just for convenience sake. But this could theoretically be any actual resolution we want. It could be twice this resolution, half this resolution. It doesn't technically matter. It does matter for performance, but in terms of the programming, it doesn't really matter all that much how different these two sizes are. Anyhow, so here we're gonna go depth buffer dot begin camera contour. I admittedly do not know what most is it begin draw? Hold up, let me jump to the documentation here and see what they do. Yes, it's begin draw end draw. So down here we go buffer dot end and draw, which this is tell the GPU to render the buffer. that's what effectively this is. This starts collecting information to send to the GPU, and this actually sends the information to the GPU. So then what we do is we say, is in the depth buffer, we tell it to use the shader, depth buffer shader. There we go. And then I think we need to replicate basically most of these commands on the depth buffer, which is the very complex part. So my eventual plan, theoretically, if I get this working well enough, is that I will create my own version of a P-graphics object, which is basically what you use to render stuff anyway, that takes all these inputs from like box and fill and stuff and will duplicate them to parallel or we'll duplicate them to one, the main graphics object, and two, the depth buffer object. So depth buffer.camera. This is quite important that they have the same thing. Otherwise, the results will be very weird and different. Okay, so depth buffer camera. The light stuff theoretically isn't necessary. Light is not necessary for the depth buffer, as it has no effect on the actual end result of where the depth of everything is. Note, some light info will need to be... Now, specifically what that is that's for directional light in particular. We will need to know what direction the light is in. So I'll have to figure out how to send that information in for when we render it. I believe there's also, because it's not a point light, it is instead, again, directional light, I think we need to render the scene first render it orthographically, I believe. So, yeah, I don't know how to do that. Well, I do. I know this processing has a way to do that. I don't know how to, render it orthographically one way and then convert it to another way. Oh, chat taking so long to load. Well, Tyler, if it's on your laptop, that would make sense as to why. But anyhow, so that's with this. And then for all of these commands, again, color, also color like fill, that's actually not important either. We only care about the existence of an object, maybe its transparency. Probably not really going to deal with that all that much. So just the existence of an object is really all that we care about in terms of the depth buffer. So information like color and lighting, which is another form of color, is completely irrelevant to the depth buffer. So so we're gonna have to do basically copy all these commands, which is why I want to have like an object that automatically does this copy for us. So we only have to issue the commands once, and then they're automatically duplicated. So forgot the dot there. Depth buffer box, depth buffer translate. And this is kind of annoying because if I want to modify this shit at all, I have to do it on both. Otherwise, the theoretical results we could get would be strange, confusing, strange. So if I potentially we should make sure to look at this in case we're doing stuff. Anyhow, so then we render that. Then what we're gonna need to do is we're gonna need to say shadow shader dot dot set. We're gonna say depth buffer, and then pass in the depth buffer itself. What specifically I believe this is taking in is the depth buffer as an image. So a texture that we can send in to a shader, which is obviously something that's quite common to do. Send the rendered But now, importantly for this, we will need to go over into the shader for the specifically the fragment shader and have a uniform depth buffer, or wait, it's uniform sampler 2D, I believe. Yeah. Does it kit? Okay. I believe this is the an image type in OpenGL is a sampler 2D. I know this is unused, but theoretically, this is what we'll need to use in order to determine whether to put stuff in the shadow realm or not. I don't remember how you do. I don't actually know how we're doing this, which is why I'm either going to search this stuff up on the internet, or I'm just going to ask an AI to produce some code that doesn't work and start questioning it thoroughly. Anyhow, let's just make sure I didn't do anything weird. Yeah. It doesn't have a uniform called depth buffer, or the uniform was removed during compilation because it was in use. It was definitely removed during compilation because it's unused. I don't know. AIs aren't that good at doing Minecraft modding, Tyler. Also, you could just unmute and say this stuff. I am actually still on the call on Discord unmuted, Tyler. You don't have to type. I mean, if you want to give me that artificial engagement by typing in chat, okay, but you don't have to. To the AI to ask it to write me a OpenGL shaders for a depth buffer and processing. Start with the Google one because that one's slightly easier to get to because I'm signed into a Google account. Alright, you can't see this because it's off screen, but hello JSD, how can I help you today? Write me OpenGL shaders processing to implement shadow mapping. It thinks OpenGL is a typo. CHADDERS. Shaders, sure. Alright, go. Let's see what this comes up with. It probably won't be anything particularly useful, but I'd be glad to help you craft OpenGL shaders for shadow mapping and processing. Here's a comprehensive guide for incorporating the best aspects of the previous response. For what? Previous responses? I know I've potentially asked in the past about this, but not recently. What? And this is a new chat. So that is very confusing. Very, very confusing. Anyhow, that's a little bit of necessary information there. Okay, so going to the shaders themselves here. This is a vertex shader that's showing me for some reason. There's model, view, and projection. This is for the vertex shader. I don't know if this is for the depth buffer. Let's see, what does it do? It says the fragment position, which is the GL underscore position, I guess, is the model position multiplied by APOS. What the hell is APOS? It's just this variable it uses named APOS. It isn't defined anywhere in here.
Oh look! A rare sight!
Hey.
Oh why man!
Hello Jaredy Cool, I'm live once again doing stuff. I don't know why Tyler
I called him YY Man then.
Yeah, I don't know. This just created a random variable. Which is fun.
YY Man is literally just showing
that's a layout based value, I guess. I know there's nothing interesting on screen right now, which is fun. And also outputs a normal transpose inverse of whatever the model thing is. Okay, it loads the shaders. It does I honestly have no idea what it just spat out at me. It is completely confusing to me what this AI gave me. Let's try ChatGPT. I'll give it the same prompt and see if it gives me anything useful. Shutters. Actually, no, I'll make it a better prompt. So let's see, I am trying trying to make an implementation of shadow mapping. Shaders. Let's see. Shaders, whatever. Shadow mapping shaders. How could I go about this? Let's see what the AI responds with now. Okay, it's not going to give me any code, but at least it's going to give me kind of like steps for what I have to do. Implementing shadow mapping. You'll need to use processing shaders. Both the vertex and fragment shaders to keep these manageable. First, we'll ensure your 3D sheet without shaders renders properly using bit. Yeah, okay, done that. Share shadow map setup. Shadow mapping involves rendering the scene from the light's point of view and viewing and storing the depth information in a texture. This is called the depth map. Okay, and then render the depth map from the light's perspective. You'll render the scene from the light's point of view and store the data of each fragment in a texture. This depth map will later be used to determine whether a fragment is okay. And then render the scene from the normal camera's perspective. Yeah. You render the scene from camera perspective. For each fragment, you project it back into the light space and compare its set value with the values stored in the depth map. Oh, okay, that's how it works. That's the key thing I was expecting. So with this, we're specifically rendering from the light's POV. And then we have to do a conversion between the actual camera space to light space to check things. Okay. Here's a breakdown of implementation. Creating the shaders. That's actually a correct vertex shader, I guess. Hold up. This is for the depth map, so the depth buffer, as I called it. The vertex shader. So we have version, which is not technically necessary to specify. I will get rid of this copyright information. It is going to be irrelevant. Position. We have the attribute position, yes. I don't know what the light space matrix is. It has that. It also has a model, which we have transformation matrix, which I'm assuming is the same thing as the model. It's a map for uniform. But there's also, wait, no, this has, oh, no, okay. So we need a uniform. So I'm guessing the model is the transformation matrix. LIG space matrix. And then we have the position as in, we also have the color, which just gets passed along because that's just how that's how processing works, at least. So then this is gonna also take the light space matrix into account. I don't know exactly what the model thing that it's giving me is. Obviously you can't see, this is on stuff that you can't see, but actually, it takes the position in as a vec3. Here it's a vec4 automatically. I think processing is doing this, so that's fine. So we just multiply these things, and then that's the position of the actual vertex modification. And then for the fragment shader, which is this one, we just write the Z position. So GL, well, frag depth, frag color. Depth shader is that. It is create graphics, blah, 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 blah. Begin draw shader, render your scene here from the light's perspective. For example, a box. There's a box and then there's that. In your main rendering pass, you'll project. Okay. I don't know. Yeah, it doesn't really go over how I give it that light thing. Actually, what I want to do first is I want to actually just try rendering because obviously it's trying to get a color out. Obviously it is an image, but it wants the depth from the Z coordinate. GL frag chord. Okay, so what we'll do here is we'll say GL frag color, because actually, let me see. Does my OpenGL language thing in Notepad++ here automatically highlight GL frag depth? Oh, it does. I failed to see how that's going to be particularly useful for me, though, because I don't know. We'll see what happens if I just do this and say GL underscore frag chord dot Z. We'll see what happens if I do that. And actually, I'm going to go come back here and we're going to get rid of the light space matrix for now, actually. As a kind of temporary thing here, I want to just see what this looks like by default before I start messing around with other matrices and stuff. So, whoops. Oh, I have DMs. Yeah, okay. Alright, get that back up there. Alright, so what we're going to do is we're going to just, instead of rendering this here, we go to processing here, and what we're just going to do is we're going to go camera. We're going to reset the camera. We're going to go hint disable. Yep, hint disable depth test, and then we'll make sure to turn it back on afterwards so things don't get weird. And then we're just gonna image, just draw the depth buffer to the screen for now. it's almost... And see what gets produced, if anything, because... Yeah. Nothing. Oh, God. But yeah, there should be something here, basically. If the depth buffer was working properly, then we should have... at least everything in the background should be, I guess, black or whatever. But we didn't set any color, though. So I'm not exactly surprised about that. So then, instead of fragment depth, instead of setting that, what if we set the color equal to... I know that's going to be a single one. So what color is... Yeah, color is a Vec 4. So... It's not going to be right. I feel like... I don't know if colors in OpenGL are ARGB or RGBA. Googling. Color vector format. Oh, god dang it. No thanks, Google Chrome. I want to type in the search bar. Jeez. Color channel order. For each RGB. Well, let's just see what this does for now. If this doesn't render me anything, well, then I think we know what's going on here. Okay, Tyler's heading out. Yeah, we're just getting the same thing.
You're just reading that now.
You see, I'm in streamer mode on Discord, dumbass. And I'm also looking at other shit. Jeez. I don't know if the background is just defaulting to it. Actually, so let's, in the shader here, let's just go set everything to 0. Why not? Set everything to 0. So this should just produce me black, right? No, it produces me white for some reason. Well, that's strange. Let's try a 1 there and a 1 there and see what color that comes up with then. I know I've had weird things where it like optimizes out or just doesn't do crap. Yeah, like this is strange. This should just produce a color, an image of some color, not just white. Just to make sure that I'm not going crazy here and the whole sketch isn't bugged. Yeah, okay, that is just the image there being entirely white for some reason. Just to make sure that the vertex is still definitely the same. You know what, let's just see if that does anything. See if it renders anything. Hold up. Oh, it's just completely borked. Look at that. Weird. This is the thing. Debugging shaders is very difficult. Okay, even without that, even without a shader, it's completely screwed. Hold up. So let's give it black background. Okay, it's not even running through a shader at this point. I am very confused all of a sudden. Yeah, it should just be... You begin draw on the depth buffer. Yeah. You do your drawing things as normal. Then you end draw and can use it as an image. Oh, here, let's comment that out. Why is it producing only a white image? I'm actually very confused right now as to why it's not doing anything. I could say... Or why it's giving me a black background. Oh, I know what's going on. This shader's happening. That's right. There we go. That's what I was expecting. This is pink. Doesn't matter. Oh, right. So... That's right, because we're not rendering anything textured like an image in the main shader right now. Oh, that makes so much sense. It was me. It was all me the whole time. So... we go back to this. Okay. Gives us that. I will keep the background color at 0, because that I guess does stuff. So if I set this now to 1 followed by a bunch of zeros, this is still the color that it comes up with for some reason. Strange. Oh wait, that's right, I disabled the shader. That's right, re-enable that shader. What do we get? Black. Okay. That, I think, might actually be the alpha channel. Do we get red if I do that? No. Well, I should have... Okay, now we're getting to the issue that I was thinking we might have had before, where it's optimizing out doing anything. Okay. Oh no, the last one, that's supposed to be white. Hold up. The last one's alpha channel then, right? Yes, the last one's the alpha channel. Annoyingly, we're also going to get stroke in here, but we can just turn off stroke. And that's all we really need to do. Okay. So now, so we got to keep that as 1. GL underscore frag chord.z. I should probably replicate this to all channels, but that's effort. Okay. Well, we have red. Come to think of it, I have zero clue what the actual result is. What if I go back to rendering, or if I go back to setting a depth instead of a frag color? God dang it. Processing. Play. I don't get anything. About what I thought. So here's the thing, kids. I have zero goddamn clue what the frag chord or what the value of frag chord is. I know the result of a color is supposed to be between 0 and 1. I don't know what a frag chord is in terms of color, in terms of depth. How does it say I should... Well, it did say I should create a P graphics. When we send in the shadow map. Well, let's just start asking ChatGPT questions then. Oh gosh. Okay, I just shook my entire desk. Is the camera okay? I'm not looking at OBS right now. Yeah, camera's fine. Okay, so what I'm gonna do is I'm gonna ask ChatGPT here. Let's see, what are we gonna ask ChatGPT to fix this? Let's see, what does it call it? For the depth map, a sing fragment shader only outputs a color through GL frag color, which is a vec for all values ranging between 0 and 1.
Pretty cool.
Yes, Jaredy, cool.
Watching the LCT video about Wi-Fi stuff.
Yeah.
Got me like an hour and a half looking stuff. So apparently, at very least, the access point inside my bedroom for 2.4 gigahertz is on channel 10.
Ooh, that's kind of strange.
Yeah. And looking also at the 5 gigahertz band, all like the local networks that are on 5 gigahertz sit on the same like channel 48.
Oh.
There's a couple way up, but there's just like everybody's sitting on the low end. Anyways, so I went and looked to see if like into the app to see if it's possible to change it.
Okay.
For our access point.
Yeah.
It doesn't look like it is. So the default settings for each level are what you get for the spectrum, or for the actual physical channel for our Wi-Fi.
Oh, hang on. Let me look at what you're trying to... Oh, you're not trying to show me anything right now.
I'm not. I'm just playing Minecraft.
Okay. Nothing.
Anyway.
Major changes needed for the vertex shader. That is expected. I mean, I still need to figure out what the light space matrix and the model and all that sort of stuff is. But it's probably just like rendering the scene from the light's perspective, to be fair, so we figure that stuff out. Okay, so this is some updates to what was going on. So we make a variable for the depth. And then it does this. A vec4 of the vec3 of depth. Well, we'll see what this does. I doubt this is really gonna make a difference. Yeah. I don't know why it's also red as well. That's not white. Oh, wait, no.
I think I just found the feature that lets us actually make it work properly and get to a different channel.
Nice.
I'm not going to run it without not letting Dad
Okay.
know, but...
Oh, no, actually, okay, this is actually... I was expecting it to be a bit more drastic than this, I guess, but no, this is an actual, like, gradient of color here. It is, for some reason, a lot more red here compared to out there. I need a color. Shift C? Yeah, color picker here. So that's actually very convenient here. I don't know if OBS does, but obviously, okay, we have black here. But then back here we have like FF, DC, DC. But then as we get closer to the camera, everything but the red channel starts to decrease and get darker. Interesting that things farther away are brighter compared to closer, but I guess that's how you do it. So actually, we can play around with this stuff by making this thing bigger, moving it around a bit, and I think we'll do that a little bit here. So just to have a little bit of fun. So we'll do this with the box in the first box, which is this one here, yes. So we'll double it in size just to really get a range of this. Okay, and then we'll push it a bit farther away. So we'll go 600, 600, oh, not that. Depth buffer translate it 200 away. And then negative 200 back. We're going to flip that so that it's negative 200 away and 200 back. I obviously have no goddamn clue how my color spaces are working here. But what I find very interesting is that the red channel is remaining. The red channel remains at 100% the entire time, while the other channels aren't. That is strange. But yes, anyhow, I guess this is like a functional depth buffer now, which is good. Just gotta figure out what it actually means to be rendered from the perspective of the light source. And then to also then have that transformation be made later. But first of all, I want to figure out this. If I set this to 0.5, will that just be like 0.5 transparent? Yeah, that's just transparent, which looks weird. Why is this going on with red though? Again, problems. You can't really get much debugged output out of this. Again, actually, literally, quite literally, the only output we have from this right now is color. So no, we want that to be good there. So we're gonna say depth, depth, depth. And we'll see what this does. Still red. which is very confusing. What if I say 0 depth there? Will this be great? Will this be weird now? Well, it is indeed 0 on the red now. And everything else is still changing into what it's supposed to be. But why is it, when I put depth here, why is that always like going to... Okay, this is just mild now. I'm so confused actually, like what the hell is going on with this? So I'll put that back as depth, and we're gonna get it as red again, or pink, because red is at 100% the entire time for some reason. And then we're gonna just say what happens. See what happens if we multiply it by 0.5. We get this sort of a color again. Why is depth acting like a constant when it's here, but a variable for these other two? So here's what we're gonna do. We're gonna just or is something forcing after this? But no, it's only when we use this that it's a constant as 1. Otherwise, it'll make it a constant as 1. Anyhow, so depth 1, 2, 3. Now what do we get? Still get it as pink. Yeah, I don't know. I mean, there's like nothing I could really do to make it render any different. I just want to see if like putting something like very close to the camera here will actually make it like really dark red, I guess. So, okay, I guess it will stop being dumb here then. Well, I don't know what's honestly going on, but this depth buffer thing in terms of being a vertex or a fragment shader looks like it's working well. I just want to see what happens if I then go if we translate this close to the camera, so that'd be, we'll do it a little ways in front of the camera, so that'd be like 290 negative 180 290, I guess. Depth buffer box. We're not even going to do 10, we're going to do 5. Just because it's that close to the camera. And then we'll obviously undo our translation. And this has taken a bit of a turn. Alright, let's see what this does now. Oh. Crap, it's too close to the camera. It's not visible at all, I think. Let's back down on all these. There it is. Ooh, it's dark. Wait, why is this? What? So those two channels are always the same. But like, red starts getting involved once it gets close to the camera. What? Now I'm confused. Like, extremely confused. What the actual value is depth? And how do I figure that out? Oh, I clicked with that, huh? Let's see, if I make this a size of 10. So this is all the way down in 9.8. I honestly have no goddamn clue what to say about this. It is actually quite perplexing what's going on here. And like I was saying, wait, so 9A there. But this thing gets down at closest to C2. But the red is actually changing in here. And I don't understand it. What is going on? Why is the value of depth different for red than it is for everything else? And they change independently of one another. Okay, hold up. I have to... Just gonna have int d equals 0. And we're gonna have this be plus... Yeah, plus 10 times d modulo about 60. That should move the box up and down a bit. I forgot to increment d. Oh. I'm so sidetracked right now. Okay, that's just sending it downwards quite fast. 3. What happens if I go up to like 180 with it to start with? Let's get rid of the multiplier and mod it by like 180 actually. So sidetracked, so loving it. Here's the thing. I mean, its color is definitely changing over time. This thing is still 100% on that. What the hell? Okay, well, nevertheless, that is a functional depth buffer, I guess, is what I was trying to say. I guess for the depth information, maybe we just like add blue and or add green and red together. I don't know. Or I guess we first check red, and if that's different, we'll go with that. I am utterly confused about that. Anyhow, yes. This box is going to remain firmly in its position of being exactly the same size as it was before. Let's just make sure I did that correctly. Alright, good, because we can kind of see a gradient there already. Alright, let's see that. Okay. Okay, gives the depth fragment in screen space. We store this depth in all 3 color channels by creating a grayscale value where 0 is close and 1 is far away. Yes, that is the case. When you render the scene, you'll use the grayscale depth map for shadow comparison. The depth texture will represent the distance from the light to each fragment. Or, yeah. In your shadow comparison shader, you'll sample this depth map as a texture and compare the depths. Rendering the scene with shadows, and then that goes into the is this a in the fragment shader for rendering the scene from the camera's perspective, you can sample the depth map and perform the shadow tests. Okay, let's go kind of implement that, I guess. So we have, well, I need to look at what the previous shader or vertex shader is, because I didn't look at the vertex shader for the actual shadowing thing. It created a frag pause light space, which is something called frag pause, which is the model times position. Okay, well, I guess first, before we do anything else, let's get the vertex shader. Okay, for the vertex shader, okay, whatever. Pressing provides a map for a transformation matrix and a vec for position. Actually, we can go look at this to see all the things that it could be providing. Texture stuff, not relevant here. Normal matrix as a mat3. Looking to what it said I should have for the vertex thing, which is GL position. It wants me to have a light space matrix and a model and also a position. I don't have the model, and I don't know exactly what the light space matrix is, but theoretically, we have there is a possible model view matrix. I don't know where is that used? Not in there. EC vertex. What is EC vertex used for in here? Basically stuff with fall off stuff. Okay, that might be that. I will say, and a map for model view matrix. Because what it basically is seeing, basically from what I can see here, is it's basically just multiplying light space model and converting position into a vec4. How do I, or what is the, it asks for a light space matrix. What is light matrix, and is your model EL the same as things model view? Okay, we'll ask it these questions to see if it gives me some straightforward answers here. Provides matrices, and it also, no, it doesn't provide a projection matrix. I don't think. Wait, no, what does it? I'm confused. It no, I don't think it provides a projection matrix. It just provides transformation, model view, and then also position. I mean, obviously it's providing like all of this crap as well, but are part of built apparently projection matrix part of built-in variables to handle transformations from object space to camera view space. Understanding matrices and processing. Here's a breakdown of the matrix. Model view matrix. This combines with both model matrix and combines both the model and view matrices. It transforms vertices from model space to view camera space. Projection matrix, which I've never seen. This matrix projects the scene from camera space to screen space, especially applying the perspective on orthographic projection. Okay. Transform matrix. This matrix is the combination of model view matrix and projection matrix. Oh, okay. So model view and whatever projection is already in transform matrix. Effectively transforming vertices from model space directly into clip space. What is the light space matrix? The light space matrix is a matrix that transforms coordinates into the coordinate system of the light source rather than the camera. This is necessary for shadow mapping because the shadow depends on the light's perspective. The light space matrix is typically the product of the following. Light view matrix, similar to the camera's view matrix, but from the light's perspective. Okay, so we'll just set the camera as the light source, I guess. Basically what I'm thinking is we just set the camera as the light source and switch its stuff. Similar to the camera's view matrix, but from the light's perspective, this transforms the coordinates from world space to the light's view space. Actually, having all this information directly available for both shaders sounds important. Light projection matrix projects the scene from the light's view space into the light's clip space, just like the camera's projection matrix. So basically, thus the light space matrix is light projection times light view. This matrix transforms vertices from world space, where the space in which objects are defined relative to the world, into the light's clip space, where when rendering the depth map, you will need to use this matrix to render the scene for the light's model versus model view matrix. The model matrix transforms vector vertices from object space to world space. This is a matrix that encodes the object's position, rotation, scale, and so forth. Model view matrix and processing combines the model matrix with the view matrix. This transforms the vertices directly from object to the camera space. Okay, so model view matrix processing does what both model matrix and view matrix do in traditional OpenGL. That's actually useful. Using light space matrix. Since processing does not provide the light space matrix by default, you'll have to calculate it yourself. You can pass it into a shader as a uniform from your processing sketch, like this. Oh, good. Finally, actual code that I can use to processing, please, to do stuff. So, of course, there's a P matrix. Why wouldn't there be? We'll do it up here because I don't know, why not? So PMATRIX3D. I probably didn't spell that right. Hold on. Might just not highlight it. That might be okay. I don't doubt that this is probably an actual class. Let's see, does it complain? It complains. Oh. Oh. Okay, no, okay, good. That is a class. It's just not highlighted, or processing doesn't do syntax highlighting on it. I don't know why I was expecting it to, but okay. Okay. Okay, multiply them to get the light space matrix. Okay. This seems rather useless as these things are... Okay, but how do I populate the contents of these things? How do I get the values that are supposed to go in both of these? I actually don't know those. And then, yeah, okay. And then we go... We set the light space matrix to this, but like, how do I get the values for this? Okay, well that calculates the lighting shit and sends that in, but like, actually we'll need to set this to both of these actually. Now that I think about it, this will be necessary for both of these things, I think. Because in, I think, in the actual shadow, well, in the shadow, or the shadow shader is going to need to have this matrix so it can transform points between its space and light space. Okay, you can set up light view matrix, similarly to how you set up the camera view matrix. Camera. Does camera return anything? The light's projection matrix can be either a perspective or orthographic projection depending on the type of light, e.g. bidirectional. I don't know how to set up these matrices. And I have a feeling the camera... Okay, well... So, github.com/processing 4. I'm going to just start looking through processing code, seeing if this helps. Processing, OpenGL, PGraphics 3D. I think that it has to be PGraphics. OpenGL is where we're gonna find the default camera command, I think. There's a lot of camera related variables here. There's begin camera, but that's just a void. Yeah, I think all the the cameras are just voids. What does the actual camera command do, or camera method do, even? It's not a this. Oh. Wait, there's a print camera. There is an ortho. There is a way to do orthographic projection, which we're going to need to do for the light space anyway, because it's a directional light and not a spotlight or locational light. So it does a lot of calculations. Model view dot set, and then okay, and then it has a 4D matrix of all this shit. We're not gonna end up using model view? Wait, no. Well, is there a way to get the model view? Because the model view, by the looks of things, camera.set. What is the camera object in here then? Oh, camera is just a P matrix. Wait, so can I do, say, G dot... It is a public. Okay. So okay. So what is ChatGPT saying for the light view matrix? This is just camera. So actually I'm going to take all this shit down here to after this camera. Actually, after both cameras, because they both need to be the same thing. So if we're gonna say, so light view matrix is actually just gonna be, wait, is that model view? I think that's actually just going to be... Wait, what is... Okay, I'm confused again. What did ChatGPT say model view? So model view matrix combines the model matrix and the view matrix into a single model view matrix. This transforms directly from object to camera space. Ah. Oh, wait. Camera space. That's what we want. Yes. I think that's... So, yeah. Okay. Because that's not the projection type yet. I think that gets multiplied in to transform matrix. So, what we're going to want to do is, if I look here, yeah, there's just camera, which is just directly a P matrix 3D, which is what we're working with here. So we're just gonna say that instead of this being new, we're just gonna say this is equal to depth buffer dot camera. No, is that not gonna work? Because I'm pretty sure that's how it works in processing, where at least in pgraphics OpenGL, camera is defined as a public P matrix 3D. And P... Oh, but this is not a pgraphics OpenGL. This is just a pgraphics object. That can be modified relatively easily. Wait, what's your issue? Oh, no, there's type error. We're just gonna cast this because that's what it's gonna be. That's what we're asking it to be. And therefore we can just directly get the camera out of this, which just leaves us fucking around with the light projection matrix. Now currently this means that this camera here, this means that the shadows we're going to calculate are going to be from the exact same eye perspective as our camera. Gonna leave a note here. Note. The camera is different. Normal camera. Is the I wonder if it would be more efficient to just tell processing to put this camera into orthographic mode or whatever and just have that all in the GPU, but whatever. It is the buffer camera is going to be the camera camera is going to be the location of the light, or is going to be the view from the perspective of the light source. So there is, of course, that thing is, I will still have to worry about how far. So this and this are going to be the same. The actual focal point of the camera is going to be exactly the same. The difference obviously has to be the eye location, which is going to be mathematically calculated to be approximately the same as this directional light here, which means I'll have to find the magnitude of this from effectively everything, maybe add a little to it, and then using these with some trigger something, calculate these. I think that's how that's gonna have to work, but we'll deal with that later. We'll just get this depth buffering shit working. Okay, and then in terms of the light projection, ChatGPT is saying that the light space matrix, the light's projection matrix, this, can be either a perspective or orthographic projection depending on this. Okay, their processing also really nice. Oh, hold up. Does provide stuff for generating orthographic projections, but it just sets the internal orthographic projection to create processing standard orthographic projection. Now it is long and complicated, but it ends up just setting a matrix, also public, called projection. So, okay. So if I just call this ortho, I swear the GPU already does this, but since this information I guess is relevant to send to the normal shader, or to the normal shadow shader, I guess it would make sense to just keep this here, perspective. Is that it? Oh, projection, sorry, not perspective. Projection. And then we can simply set this as values in both of these shaders. That does mean that I will have to actually put these values into both shaders. Which means it should be a uniform map for, in terms of at least the depth buffer vertex shader here. Yeah. Light space matrix, and then what does it say? Well, position is already a vec4, so we don't need to actually do these conversions here. So light space matrix times model. Fuck. What was it saying was model again? Man, this is... I wonder if processing actually has model as a thing. Because model view matrix is a thing. Transforms are from model space, object model space to world space. Maybe we can just do without model. Yeah, we'll just see what happens if we don't include that, and obviously position is stuff. We'll just assume a position's already been transformed. I don't know if model space is a thing compared to world space. So what does it consider model? How does it import model again? Well, you know what? We definitely need to get this rid of the vec4 around position, as that's already a vec4. Oh gosh, it's not, I'm probably gonna... Okay, I think this has been actually a largely successful stream. I've been learning a lot of stuff here. Let's see what happens now. Errors? Errors galore? Black. As I expected, black. Okay, well... My brain is completely fried. I'll probably end up working on this off camera a bit. But yeah, I think I'm done streaming for today. It has been a bit of a stressful, but hey, I learned a bit of stuff that is sometimes maybe useful. I don't know. I'll probably try to do this again off camera where I'm not as stressed out. But yes, interesting stuff. Anyhow, with that, I guess I could say thank you all for watching. Hope you enjoyed. Please make sure to leave a like on the stream on your way out and subscribe so you can catch future live streams where I'm hopefully doing a lot more competent stuff than this. I don't know what I'm doing. And yeah, I'll see you. I guess I'll see you around in the next one. Bye.